Okay, we're gonna solve 5 part A. 1 plus cosine theta over 1 minus cosine theta is equal to bracket cosecant theta plus cotangent theta bracket square. I copied down the question already, I'll just scroll down. Let's take a look. You notice straight away that there's cosecant and cotangent, right? So let's just clarify what that is. Cosecant theta, remember, co on one side, no co on the other side. So it's 1 over sine theta. Good. Next one, you have cotangent theta, co on one side, no co on the other side. So it's 1 over tangent theta. Good. Hey, but wait, you notice something else. Tangent theta is really just sine over cosine. So if it's 1 over tangent theta, it's really just cosine theta over sine theta, right? So I can replace this with this. Huh? But yeah, that's all I'm gonna do. Let me just change. Alright, and what I'm gonna do to save some space is I'm just going to replace this cotangent theta with cos theta over sine theta straight away. Few other identities you should know, keep at the back of your mind is sine square theta plus cosine square theta is equal to 1. That's your Pythagorean identity. Then you can divide throughout by sine square, and what will you get? What will you get? Copy, paste. Divide by sine square. Divide by sine square. I'm just distributing the 1 over sine square to each term on the left side and right side. And what do you get at the end? You should get, they cancel off, you're left with a 1. Cosine square over sine square, you're left with a cotangent square. 1 over sine square, you're left with a cosecant. I forgot my own identity. If there is no co on the sine, so there must be a co on the other guy. Cosecant square theta. Okay, just to make things neater, I'm gonna erase the working and just write down the conclusion, which is 1 plus cotangent square equals to cosecant square theta. Okay, the divide by sine square, I'll just remove it as well. And the next step is to consider, if you divided by sine square, what's the next thing you could divide by? Divide by cosine square, divide by cosine square theta. So what will you get? Again, copy, paste. Then you divide by cosine square. Divide by cosine square. Divide by cosine square. Good. First term simplifies into tangent square, right? Because sine square over cosine square you can rewrite as sine over cosine first, then the whole thing square. Then sine over cosine inside is just tangent square. Alright, then the next guy is cosine square over cosine square. They'll just cancel off. You're left with a 1. 1 over cosine square. Co, no co. Cosine square already have a co, so no co is secant square theta. So that's the answer. Now let's just remove all the other terms. Remove. You're left with tangent square plus 1 equals to secant square theta. After you divide throughout by cosine square. Let's just delete the cosine square working as well. So that's how you get the 3 identities. Good. So now that you have all these identities in your arsenal or your toolbox, you try to work with the question. Try to find out how do you go from left side to right side or right side to left side, or maybe even meet in the middle. You work with the left until you reach a certain expression, then you're stuck. Then you start working from the right hand side. You start solving, rewriting it until you eventually reach the middle. You can meet in the middle. Meet in the middle. That works as well. But most people, I think, usually, most people, if they're stuck, they will just do meet in the middle. But preferably, this is a bit dubious. It's some teachers may say you have to do it from left side to right side and right side to left side, but I say either is fine. And in this case, I'll just do it the classical way, which is to do from one side, and you show it's equal to something, until it's eventually equal to the left hand side. And this notice I picked right hand side to start off. Why? Because the moment I see this fraction here, I got confused. I don't know how to continue. I don't think I can do much with a fraction, so I'm just going to start not touch it. Instead, I'll work with the right hand side because I see that there's a square. So maybe I could expand out the square, right? So let's just do that. Let's just expand out the square. Cosecant square theta plus 2 cosecant theta times a cotangent theta. Don't need to draw that dot, plus a cotangent square theta. Now in this case, is this useful? Is this useful? Well, I tried it before starting the video and I realized it's not that useful. Maybe I could have replaced my cosecant square with what, 1 plus cotangent square, right? Then the cotangent square, I can add them together. I'll get 2 cotangent square. But I still have a cosecant in the middle. I find that very difficult to work with. So no, substituting cosecant square doesn't work. What if I decided to, I don't want to substitute cosecant square, I want to substitute cotangent square. Cotangent square is this guy over here in the middle, so I can make that the subject is just cosecant square minus 1, right? In other words, I can replace this with cosecant square minus 1. But wait, okay, I have cosecant square, I can combine them, that simplifies things a little, but I still have this cotangent. Cosecant, wow, so complicated, I don't know what to do. It's still minus 1, it's a 2 in front of them. There's so many things, I don't know what to do. So what I choose to do is, I give up. I give up on this method of expanding the square. Instead, before I expand the square, delete this whole thing. Instead of expanding the square, I realized that, hey, take a look. I have cosine. And the basic Trigo ratios is sine, cosine, and tangent, right? I have cosine on the left-hand side. So I wish that everything was basic. It was just sine, cosine, and tangent. Not something so complicated as cosecant, cotangent, and I have to memorize something extra. So complicated. So that's when I try to simplify, with that idea in mind, I try to simplify my right-hand side, the cosecant theta and the cotangent theta, into something simpler that I'm more familiar with, into the sines, cosines, and tangents, right? So in this case, I realized that, hey, before I expand out the square, I could just replace my individual terms, right? Cosecant theta is really just what? 1 over sine. Cotangent is what? 1 over tangent, but we already clarified that it's actually cosine over sine. Oh, good. So we have two simpler fractions in terms of sines, cosines, and okay, not even tangent. Tangent can rewrite as sine over cosine. So everything in terms of sines and cosines. Oh, so in this case, I notice that I have a fraction and both of their denominators are sine. What can I do with that? I'll just add the fractions. That's the only natural thing that can happen when you have two different fractions. You add them together, right? Common denominator already. You don't need to try and multiply by a certain factor to make them the same. So my life is easy. It's just 1 plus cosine theta in the numerator. Then the whole thing, bracket, square. Of course, I can expand out the square. So what do I get? I'll get copy paste, top, square, bottom, square. But wait, I like to write it in this fancier way. Sine square, the 2 in the middle. Both are equivalent. Sine theta square and sine square theta, they are the same. Okay, then after that, I'm going to continue. Wait, you realize I want many cosines. But here I have a sine. That's bad. I don't want sine, I want cosine. How do I get cosine from a sine square? From a sine square, how can I get a cosine? Very easy. Take a look at this identity. Can you see how I can use my sine square and make it into a cosine? Of course, okay, I'll just review it. What you have to do is to replace your sine square with 1 minus cosine square theta, right? Remember this form, remember I said that the sine square plus cosine square theta equals to 1. This form is not that useful. It's nonsense. It's bad. Instead, what you should use is sine square theta equals 1 minus cosine square theta, and cosine square theta equals 1 minus sine square theta. Okay, I'm not saying that you will never have to use this particular form. There are some questions which require you to use this form, sine square plus cosine square, and then substitute it with a 1. But it's not common. This is not common. Instead, what is more common is for you to have expressions involving sine square and cosine square, then you just replace with 1 minus cos square or 1 minus sine square respectively. Just like in this case, you have a you have a sine square, you replace it with 1 minus cos square. Okay, good. So now let's just simplify the fraction a bit. I'll make it a little bit neater by rewriting the fraction. Like this, okay? So you notice, hey, the denominator, there's something very interesting about it. 1 minus cosine square. Do you agree with me that it is simply just 1? Oh, it's simply just 1 square minus cosine square? Yes, because 1 is the same as 1 square. And wait, isn't that the same as a square minus b square? What's that equal to? A plus b times a minus b. Oh, so I can always rewrite my 1 square minus cosine square as 1 plus cosine times 1 minus cosine. In other words, numerator stays the same, but the denominator changes into 1 minus cosine times 1 plus cosine. Okay, you realize, top and bottom, 1 plus cosine, 1 plus cosine. Oh, I can cancel off one factor of 1 plus cosine, right? 1 plus cosine is one factor. So you can cancel off one of them, 2 becomes a 1. And there you go, 1 plus cosine theta over 1 minus cosine theta. That's exactly what we wanted at the start. So it's equal to the right hand side, and we are done.